Hey folks, Mr. Dell here. We are looking at a problem that deals with complex numbers and doing some simplifying of them based on the operations that we have here, some computing, adding and subtracting and multiplying complex numbers. So again, remember a complex number. Oh, this is a problem I'm taking from Math, CPM, Math 2, and this is section 6.1.4 and number 6-45 or number 45 here. So complex numbers, as I was saying, a complex number is in the form of a plus bi, where this I, the component, this I term is that imaginary number. So a plus bi. So that's the form a complex number is always in. So in this case, though, not to get confused, but now they're just using these variables a and b as the variable, right? So they're saying this a variable, this variable is 2 plus 3i. This other variable b is I, 1 minus I. So they're in the form of a complex number. So that's what these variables are. So a represents that and b represents that. So when they want me to do, they want me to compute each of these. So they want me to take a and add it to b. So in other words, take a, which is 2 plus 3i, and add it to b, which is I minus, or 1 minus I. So let's just write that out. So it's 2 plus 3i plus 1 minus I. So at this point, now we're adding these complex numbers, which really it's just like combining like terms, right? My like terms are the integer piece, the real piece here. So it's 2 plus 1, which is 3, right? So I'm adding the numbers, the part of the complex number that has no imaginary component, no I to it. So those two become 3. And then the other ones now are this 3i and a minus I, or 3i and a negative I. So it's really a negative 1i or minus 1i. So this now becomes 3 plus, so I have 3 plus 2i. So there's my final number there. It just needs to be in this form, the standard form of a complex number, which is, there it is. There's my a plus bi, or my complex form. So a minus b. So once again, now I'm going to take a, which is that, and b, which is that, and do the math. So be careful though. So this a is 2 plus 3i, b is 1 minus I, but I'm subtracting. So when you subtract, you're subtracting the whole number. So I'm using parentheses to show that. So I'm taking this, I mean, I could put parentheses around this as well and show you that I'm taking those two and subtracting them. The first set of parentheses are not needed because there's no operation in front of that parenthesis to deal with. But this second set of parentheses is needed because I'm subtracting. So I'm subtracting that whole thing. So if I want to, I have to distribute that minus. So it becomes minus 1 plus I, right? So that minus goes to the 1, and then the minus minus I, right? Minus minus I becomes plus. So that's how that looks, okay? So now I can again combine these like terms, which are the components without i's, 2 and negative 1, or 2 minus 1, which is 1, and then the 3i and the positive 1i, which is positive 4i, right? So there's that one. Last one is a times b, right? So this is the same thing as saying a times b when you have two variables next to each other. So the a is 2 plus 3i, and the b is 1 minus I. So it almost looks as if we're multiplying binomials, right? A complex number kind of has the form of a binomial, your real term and your imaginary term there together, right? So the whole thing is this binomial. So we can multiply it using the generic rectangle, or we can just do the distributive property, either way. So if I'm distributing the 2 to each of those, and then I'm distributing the 3i to each of those. So 2 times 1 is 2. 2 times this minus I is minus 2i. And then I take the 3 here, 3i, and multiply by the 1. So I have plus 3i. And then I take the 3i and I multiply that to the negative I. So that becomes minus 3i squared. You treat that I almost as if it's a variable, right? So your I times I is I squared. Here's where it gets a little tricky. So I squared, if you remember from imaginary numbers, I squared is equal to -1. Now you might ask, why is that, Mr. Dell? So remember, I is the same thing as the square root of -1, right? The square root of -1 is I. That's where I comes from. The imaginary number is the square root of a negative number. So if I'm going to square both sides, right? If I'm squaring this I and squaring this square root of -1, well, the squared square root cancel. That's why this I squared is just -1. So this now becomes 2 minus 2i plus 3i, and then minus, this becomes 3 times -1. That I squared is a -1. So we can clean that up more, right? So I can see that when I multiply this 3 times -1 with a minus out front, it really all becomes plus 3. It's like a -3 times a -1. Or you could say a minus a -3, which is still plus 3. So here's I'm still going to write it out. And now I can do some combining alike terms here, right? So that's an I. My numbers combine, the 2 and the positive 3 become a 5, and then the -2i, positive 3i all become positive 1i. So there is how I write my last one. All right, there you go.